Now, in the previous lecture, we have seen what is centrifugal force with the example, and after that, we have started application of uniform circular motion. In that, we have first seen the application of uniform circular motion, that is, vehicle moving on the horizontal circular track, and second, we have seen well or wall of a death. Now, third, we are going to see what vehicle on a bank road. Before going or before starting this equation, this article, or solving the equation, we must know what is banked. Banked means what already we have seen, but no, sorry, we have not seen already. Suppose a car is moving straight on a road, it it may have a speed of any greater speed. If the car is moving with a greater speed straight in a straight way, then it doesn't have any harm, or it doesn't have any risk to have an accident. But with a greater speed, the car is while taking a turn, the accident may happen. Suppose this is the road. Okay, suppose this is the road. This is the road, circular road, like this. In a circular road, we have to go. Okay, and the car is moving here on this circular road. We have to take turn. Sometimes we have to take, our car is moving very fast, and we have to take a turn on a circular road, in a circular way, but the road is horizontal. Okay, road is horizontal, but we have to take a turn in a circular way. What will happen then? Due to the centrifugal force, the car may go in outside this, and the accident may happen. So here on this way part, the road is banked. How the road is banked? The road is the builder. Then what does the builder do? They build a road like this on the upward directions. The car is first, it was moving in this way like this, but when on the horizontal circle or horizontal way, when when the builder builds the road somewhat in the upward direction like this is the level of the circular road, and it is tilted from the curved surface little bit. Then now the car is here. Okay, now the car is moving on this road on in a safe way. So this much was the angle here. From this angle, it is the road is tilted, and now the car is moving in a safe way. Okay, then in the this this was the circular road which was traveling, and then after tilt we have we have banked the road, means the angle of the horizontal road is increased. That is called as a banked road. This is seen by the view of science or arts way, but not science way, by the commerce way. We can see, we can understand from this way like this. The curved road is going like this circular road, and now the it is, see, like this. Suppose this is the road, and it is moving like this. The road is like this, and somewhat it is tilted in this way, in this direction. Suppose it is tilted, and now the car is moving on this path, and then it is taking a turn like this. Okay, means the horizontal road is tilted, and this is viewed by the commerce and arts way. As seen, you can see here, But in a science view, we have to see like this: the horizontal road, and this is the banked angle. Banking of angle means theta, means how much angle it is built. The There is the coefficient of static friction also, that balances the centripetal force, and the curved road have no uniform uh, uniform surface also. Sometimes the road may have zigzag also, or it is not straight. We can't consider that road is always straight. The surface may be up and down, so we have to take care of that also. Then, so that the frictional force balances the centripetal force, and while moving, while taking the turn while taking a turn, then what happens? The it has the limit, somewhat limit, and the surface is not uniform. Friction force has an upper limit, and the road has is not uniform, means it does not have any uniform position. So the curved road is somewhat tilted, and this is called as a bank road or banking of road. Okay, now this is the horizontal road, and it is banked by the angle theta, and the car is moving now on this path. Okay, like this is moving, this is the car, it is moving. Now, how many forces are acting on this? We have to see. Okay, first, now we will see what is the definition of the banked road. The definition of the banked road is defined as the phenomena in which the edge are raised, the phenomena in which the edge is raised for the curved road above the inner edge to provide the necessary centripetal force. It is centripetal force, CPF. It is a centripetal force to the car so that they can take a safe turn. Okay, this is the defined definition. We can define that it is bank road. Once again, we can see the definition of the bank road is it is defined as the phenomena in which the edge is are raised. Okay, edge are raised for the curved road above the inner edge. Okay, to provide the necessary centripetal force. Okay, centripetal force means inwards to the car. This car here, here from this car here, from this car here, the centripetal force is acting and in inwards, so that the car may be travel safely. Okay, this is the definition of the bank road. Okay, now we will see what about the frictional force. Frictional force is not considered here, but it is not totally eliminated also, and also the air resistance. Air resistance is also there. It is not considered but not eliminated also. Now, how many forces are acting on this car? We have to see that first force, as usual, directed downwards, that is mg. Okay, weight, that is mg. Okay, here downwards direction. Second is normal reaction. Second force is acting, capital N is normal reaction, which is perpendicular to the road. Here we can see, okay, the force is acting because the car is like this now. Okay, the car is, suppose this is a car. The normal reaction may act on upward direction. Now the car is tilde, so the normal reaction will be perpendicular to the rod and it will act in this way as shown in the diagram here. The normal reaction will be act in this direction, and third will be, now what we have done here, the angle is theta. We have considered this is the normal reaction and we have to resolve these components into two components, means we have to balance. Then this is n cos theta and this is the n sin theta. So n cos theta, we know we know very well that uh, is suppose one force is acting upwards and second force is acting downwards, means they are balancing each other. So n cos theta balances the force mg, okay, and n sin theta is acting like a centripetal force, means inward. So this centripetal force also balances the centrifugal force, that is centrifugal force out directed outwards to the car or a vehicle. So now we will see to derive the equation. So the frictional of static friction, force of static friction between the tires, okay, here the force of a static friction F of S provides the centripetal force to the vehicle, okay, and here the n sin theta, which is acting in inverse direction, balances the centrifugal force outside which is directed outside towards the in this direction. So we can write that n sin theta, here n sin theta is equal to m omega square r, okay, and n sin theta, n cos theta, which is directed upwards, balances this mg directed downwards. So we can write as n cos theta, this n cos theta is equal to mg, okay, n cos theta is directed upwards and mg is directed downwards. They balances each other. So that is equation number 1. And n sin theta component, we have resolved this component. This is angle theta here. We have resolved this n, okay. N reaction means this is normal reaction. N we have resolved. Okay, we know how to resolve this. If this is the vector, in the vector we know how to resolve the vector. So this was n resolved as n cos theta, this component, and this term will be horizontal. This horizontal term is n sin theta. Okay, so n sin theta, which is acting on the vehicle, which is directed inwards, balances the centrifugal force, which is directed outwards. Okay, so we can write as n sin theta is equal to m omega square r. Okay, here we have written. Then as usual we know that omega v is equal to r omega. From that we can write as omega is equal to v upon r. Then substituting here m omega square r, instead of m omega square r we can write as omega is equal to, put the value of omega is equal to v upon r. Then what it will be, omega square here, so it will be v square upon r square, and this r as it is. So this r and this r gets cancelled and remaining term will be mv square upon r, that is equation number 2. And this equation number is 1, which is n cos theta is equal to mg. This is equation number 1 and this is equation number 2. what it is, n sin theta is equal to mv square upon r. Now we have to divide the equation 2 by equation 1. So n sin theta divided by n cos theta is equal to mv square upon r divided by mg. Then this m and this m gets cancelled. So n sin theta upon s cos theta will be tan theta. Then tan theta is equal to v square upon rg. Okay. Now we will see the various cases of the uh, this equation, the speed limit. Okay. Now the vehicle on a bank road we have seen. Okay, and now we have to see what are the cases. First case is most safe speed, means what will be the most safe speed we have to travel, means what should be the most safe speed that we have to calculate, so that the accident may not happen. Okay, for that, for a particular road, where theta and r are fixed, and we know the equation tan theta is equal to v square upon rg. Then v square will be v square, we have taken on this side, v square is equal to rg tan theta. Then under root of this, v is equal to under root rg tan theta. The problem may be asked in your exam, then you may solve by this. This is the safest speed, v is equal to under root rg tan theta. And second case is most safest angle. What should be the safe angle? Sometimes in the problems they may ask you what is the angle theta. Sometimes the radius may be given, and we have to find the angle theta, or velocity is given. In this case, this formula we have to use. Then the safest angle is from the this equation. We know the equation that tan theta is equal to v square upon rg. Then theta is equal to will be equal to tan inverse v square upon gr. So tan theta is equal to tan inverse v square into upon gr. This is the angle between the between this equation. Okay. Now third case is safest limit. We will see third case, safest limit. Now these two cases we have seen. First case, most safe speed, we have calculated this. Then angle. Now third is not safest speed, speed limit. Okay, I said safest limit, but it is not safest limit. It is third case is speed limit. We will see the speed limit.